Hey, ladies and gentlemen, this is Miss Hubbard here, and today we're going to be doing Unit 7, Notes 6. We're going to be talking about probability with combinations and permutations. So here's some important things to remember. First of all is that combinations formula, which is n choose r is equal to n factorial divided by n minus r factorial times r factorial. So it's important to remember that when you are talking about combinations, that order is not important. So we're talking about groups. We're talking about just kind of bunches of things. That doesn't matter what order we take it, it just matters the fact that we took it. Versus permutations, and I suggest having these formulas written down so you don't have to go back and dig out your old note sheets. You can just reference it right on here. And so then we get, for this one, for permutations, remember that order does matter. So now we're going to take kind of what we did at the beginning of this unit with calculating different ways, and we're going to be applying it to actual probability like we've been doing the second half of this unit. So this can be challenging every once in a while, so please make sure you're asking me questions and then you're using your class time wisely so that I can help you as much as possible. Okay, so a combination bike lock requires a 3-digit code made up of digits 0 through 9. No number can be used more than once. So what we tried to do when we made these problems was to kind of organize it so that it went in a certain order that helped you guys. Okay, so it made sense. It was logical. All right, so how many different combinations are possible? Well, it's made up of 10 digits. So we're going to do 10, and then we're going to pick 3 because here the order matters. So we're going to do 10 factorial, and then we're going to do 10 minus 3 factorial. And then this is because the order matters, that's why we're using permutations. So then we're going to calculate that out, and we're going to have 10 factorial divided by 7 factorial. So everything from 7 on down is taken care of. So you really get 10 times 9 times 8. And you multiply those out and you get 720. So there's 720 different ways you could make those byte combinations. Next, let's take a look at part B. What is the probability that all the digits of the code are odd? So let's take a look at this way. We need to think about how many odd combinations we can have. Well, first of all, how many odd numbers are there? There's 1, 3, 5, 7, and 9. So there's 5 odd numbers, but we're only picking a 3-digit code. So we're going to do 5P3 because that's the number of different odd codes we can make. So on the top, we're going to have 5 factorial. And then on the bottom, we're going to have 5 minus 3 factorial. So that's going to be 5 factorial over 2 factorial. So left on top is just 5 times 4 times 3. And that's going to give us 60. Sorry, oops. Let me use my marker, 60. Okay, but now we want to calculate out the probability. So this 60 is our success. That's us getting an odd combination, is that 60. So we're going to take the 60 and we're going to divide it by our total number of ways. So part A always represents your total number of ways. So 60 is our successes of odd combinations and 70 is our total. So when you divide that out, you end up getting 0.083. So there's about an 8% chance that the code is entirely odd. Next, let's take a look at this next one. What is the probability that the first digit is 3? So now we're saying, okay, here's our code. And the first digit has to be 3. Well, there's only one way that can happen, right? If we're thinking back to the very first notes of this unit. Well, then if I pick the first digit and they can't be repeated, that means I only have 8 choices left here. And once I pick this one, I only have 7. So our number of successes is actually just 8 times 7, which is 56. So it's 56 different combinations that start with a 3. So that's our success. So we're going to take the 56 and then we're going to divide it by our total from part A, which is 720. So 56 divided by 720 is 0.078. So that's a 7.8% chance of that occurring. All right, last but not least, let's take a look at part D. So we want to find out the probability that the code is 1, 2, 3. So we need to ask ourselves, what's the success rate of it being 1, 2, 3? Well, there's only one way that a code can be 1, 2, 3. So my success is 1, and again, my total is 720. So 1 divided by 720 is going to give me 0.001. So that means there's a 1% chance of the code being 1, 2, 3. All right, Len, let's take a look at this word processing problem. So it requires a 7-digit registration code, and the codes are 1, 2, 3, or 1, 2, 4, 5, 6, 7, and 9. So let's note that there are 7 numbers for that 7-digit registration code. So that means we need to use all of them. So when we use all of them, we have 7 total and we're picking 7. So we're going to have 7p7. So that's going to be 7 factorial divided by 7 minus 7 factorial. Well, what's 7 minus 7 factorial? Well, that's 0 factorial. So remember that 0 factorial is just 1. So really, 7p7 is just 7 factorial. So in my calculator, I'm doing 7 times 6 times 5 times 4 times 3 times 2 times 1. And I end up getting 5,040 ways. So that's the number of different registration codes that I can use. Okay, let's take a look at part B. What is the probability that all of the digits of the code are even? Well, it says that each number has to be used and no number can be used more than once. So we have 2, we have 4, we have 6. So those are only 3 numbers. And we need 7, and if they can't be repeated, we're all out of luck, right? We don't have 7 even numbers. So there's actually a 0% chance of this happening because we have a 0 success out of our 20%. So our answer is just 0. That can't happen. That's what the probability of 0 actually means. So next, let's go ahead and let's take a look at part C. So what is the probability that the first digit is a 1? So if we pick, okay, so we have our 7-digit registration code. So let's set this up as a fundamental counting principle problem. Okay, so we have 7 codes, and we're saying, okay, this first one has to be a 1. Well, there's only one way that it occurs. Because we know that this one is already a 1, that means we only have 6 choices here. And then once we choose that one, we only have 5, and then 4, and then 3, and then 2, and then 1. So you can go ahead and you can multiply that all the way down. 6 times 5 times 4 times 3 times 2 times 1. And when you do that, you end up getting 720. So there's 720 ways that the first digit of the code could be a 1. So our number of successes is 720, and that's going to be divisible by 5,040. So you can take and you can divide that out and you get 0.143. So there's a 14.3% chance that that it's going to be a 1. Last but not least, let's take a look at part D here. So we want to find the probability that the code is 1, 2, 4, 5, 6, 7, 9. So the probability of the code going in numerical order. Well, frankly, there's only one way that can happen. So our success is 1, and then we need to put it over our total from part A, which is 5,040. So when you do that, 1 divided by 5,040 is 0.0002. Now I know I went past our normal 3 decimal points, but we want to make sure we put an actual number. So I just wrote out zeros until I got an actual number. Okay, let's take a look at number 3. So a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Domingos needs to choose 12 students out of that group. So the first question is, in how many ways can 12 students be chosen? So here the order doesn't matter. We're just talking about the number of students that we are choosing. So how many total do we have? Let's go ahead and count that. So we have 7 plus 5 plus 4. So that means when you add all of those up that we have 16 total students and we're choosing 12. So now we need to go ahead and count out that combination. So we're going to have 16 factorial divided by 16 minus 12 factorial times 12 factorial. And then we end up getting 16 factorial divided by 4 factorial times 12 factorial. Okay, so 12 factorial is the bigger factorial. So everything from 12 on down is going to be taken care of. So left off top, I have 16 times 15 times 14 times 13, and then that's going to be divided by 4 times 3 times 2 times 1. Well, when you multiply out that top, 16 times 15 times 14 times 13, you get 43,680. So now we're going to take that and we're going to divide it by 4 times 3 times 2 times 1, and that's going to be 24. So when you divide that out, you end up getting 1,820 ways. So that's the number of ways that we can choose 12 students. So that's going to be our starting total right there. So next I want to take a look at the probability that he chooses 4 seniors, 4 juniors, and 4 sophomores. So what we have to do is calculate out each of these probabilities individually. So the first thing I want to do is figure out how many ways I can choose 4 seniors. So if I look back at the original problem, it says that I have 7 total seniors, and I want to figure out how many different ways I can choose 4 of them. So I have 7 factorial divided by 7 minus 4 factorial times 4 factorial.
So that's 7 factorial divided by 3 factorial, 4 factorial.
So everything from 4 on down is taken care of. So I have 7 times 6 times 5 divided by 3 times 2 times 1. And when you divide that out, you end up getting 35. So here, there's 35 ways we can choose for seniors. Now I want to figure out the number of ways that we can choose juniors. So when we take a look at juniors, there are 5 juniors and we're choosing 4. So that's 5 factorial divided by 5 minus 4 factorial times 4 factorial. So we have 5 factorial divided by 1 factorial and 4 factorial. So because of that 4 factorial, everything from 4 on down is taken care of. 1 factorial is just 1. So if everything from 4 on down is taken care of in this factorial, really all we have left on top is just 5. So the number of ways that we can find juniors is 5. Then we want to figure out the number of ways that we can get 4 sophomores. Well, guess what? There's only 4 sophomores, so we're doing 4, choose 4. And let me tell you a little trick. When you're doing combinations, if you have the same total and the same number you're picking, there's only one way you can choose. So if we have 4 students, there's only one way I can choose all 4 of them because I'm choosing all 4 of them. So that'll save you the math in the long run. So now we need to figure out our successes. So to figure out our successes, we need to multiply this total times this total times this total. So 35 times 5 times 1. And that's going to give us 75. So our success is 75. And then we're going to take and divide that by our total, which is 1,820. So 75 divided by 1,820 is 0.096. So there's a 9.6% chance that we get that exact combination. So next it says, what is the probability that all 7 seniors are chosen? So if we're picking 7 students, we want to find the probability that all of those students are selected. So first of all, the probability that we choose all 7 seniors is 7 choose 7. So that's the probability of 1. Well, when we take out the seniors, between the juniors, we have 5 plus 4. We're going to have 9 students between the juniors and the sophomores. So if we choose 7 and we need to choose a total of 12, there's still 5 students that we need. Between the juniors and sophomores, there's 9 students, and we need to choose 5 of them. So we're going to have 9 factorial on top, and then we're going to have 9 minus 5 factorial on the bottom times 5 factorial. Again, this represents the number of juniors and seniors. This represents the number of students we still have to choose in order to get our 12. So then we're going to have 9 factorial, and then 9 minus 5 is 4 factorial times 5 factorial. So everything from 5 on down is going to be taken care of. So I'm going to have 9 times 8 times 7 times 6. Then on the bottom, I still have that 4 factorial. So 9 times 8 times 7 times 6 is going to give us 3,024. And then 4 times 3 times 2 times 1 is going to give us 24. So we're going to take our 3,024 and divide it by 24, and that gives us 126. So for our successes, it's going to be 126 times 1, which really is just 126. So we're going to take that 126, and we're going to divide it by our original total, which is 1,820. So 126 divided by 1,820 is going to give us 0.069. So there's a 6.9% chance of that occurring. Now let's take a look at this last problem here. So we're talking about a bag of coins. And so we just want to figure out how many different ways can you pull 4 coins out. We're not talking about the order in which we pull those coins out. So this is going to be a combination. So we have 10 plus 6 plus 4 plus 2. So we're going to have a total of 22 coins, and we're choosing 4. So then we have 22 factorial divided by 22 minus 4 factorial times 4 factorial. So that's going to be 22 factorial divided by 18 factorial times 4 factorial. So everything from 18 on down is going to be taken care of. So we have 22 times 21 times 20 times 19. And then on the bottom, 4 times 3 times 2 times 1. So when you multiply out the top, you end up getting this, 175,560 divided by 24, and that's going to equal 7,315
ways that you can draw out 4 coins when you have 22. So let's go ahead and let's take a look at the probability that he will pull 2 pennies out and 2 nickels out. So we need to figure out how many total pennies we have. So we have 10 pennies, and we're choosing 2. So then we're going to do 10 factorial out of 10, come on, and then 10 minus 2 factorial times 2 factorial. So the reason I picked 10, because there's 10 total pennies, but we're only picking 2 of them. So everything from 8 on down is going to be taken care of. So we have 10 times 9, then divided by 2 times 1, which is really just 90 divided by 2, so that's going to give us 45. Then we want to figure out how many ways we can pick 2 nickels. Well, there are 6 total nickels in the bag. So I'm going to do 6, and I'm choosing 2 nickels. So how many ways can I choose 2 nickels? So 6 factorial divided by 6 minus 2 factorial times 2 factorial. 6 factorial divided by 4 factorial, 2 factorial. So left on top, I have 6 times 5. Left on the bottom is 2 times 1, and that's going to end up giving you 15 when you divide that out. So my success is going to be 45 times 15 up top. So 45 times 15 is going to give me 675. And we need to take that and divide it by our total. Now our total is 7,315. And when you divide that out, you end up getting 0.092. Okay, so next, let's go ahead and let's take a look at this next problem here. And I'm just going to bring this one on down while I'm at it. So let's take a look at part C. What is the probability that she'll pull 4 pennies out of the bag? So all we have to do right now is calculate how many ways we can choose 4 pennies. So we have 10 total pennies, and we're going to choose 4. So I'm kind of going through these combinations a little bit faster because I'm hoping that you're comfortable with them. So then you have 10 factorial divided by 6 factorial times 4 factorial. So everything from 6 on down is taken care of. So you have 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. Well, 10 times 9 times 8 times 7 is going to be 5,040 divided by 24, which gives you 210. So there's 210 different ways that you can choose 4 pennies out of the bag. So we have 210 total ways out of our 7,315 total. So you can go ahead and you can divide that out. When you divide that out, you get 0.2029. So hopefully you've been dividing these out along with me so that you know you're doing it correctly. All right, let's take a look at this one. Part D asks, what is the probability that she will pull 4 dimes out of the bag? So there are only 4 dimes in the bag. So if we have 4 and we're choosing 4, there's only one way we can do that. So our success is 1. And then our total is 7,315. So you take and you divide that out and you get 0.0001. Okay, so there's literally a 0.01% chance that you're going to pull out just dimes out of that bag. So this can be a lot of information. So I'm really going to ask that you ask me questions during class and you get the help that you need. So that concludes your note video today. Please make sure you take that Schoology quiz. Thanks for listening.